Hello, guys. My name is Mo Jianxin. My English name is Jason. I'm the audio solution manager at Espressif system. I'm glad to share my content with you today. Before we get started, allow me to introduce our teams. Our team researches audio, video, and image algorithms, developing multimedia transmission protocols, design multimedia software framework, and integrates AI to create solutions for smartphones, children's education, home security, and robotic voice systems. Today's sharing is divided into four parts. Introduction to ESP GMF, the components of ESP GMF, the GMF workflow, and example and performance. The first part is introduction to ESP GMF. What is GMF? Yeah. GMF, formerly known as the ESP General Multimedia Framework, is a general software framework developed by Espressif for the IoT multimedia field. It's offered highly flexible and adaptability, specifically designed for IoT chips with minimal RAM usage of just 7 kilobytes. ESP-GMF can be applied to audio, image, and video products, as well as data stream products. Let's look at this system diagram. The GMF core is the basic framework of GMF. It primarily consists of modules such as GMF object, GMF IO, GMF element, GMF task, GMF job, GMF pipeline, and GMF port. The GMF data bus provides as unified data access interface, while the GMF pool manages intent elements and IO stream, and is used to create GMF pipeline. The GMF classes are specific instance classes of elements and IO streams. This chart shows the classy relationship of each model in GMF, highlighting its simple and flexible structure. GMF object is a basic class with its structure depicted in the figure on the right. The new and delete functions it provides allow inheriting classes to quickly create entity. The three module GMF elements, GMF IO, and GMF task inherit from GMF object. The GMF IO classes is an abstract implementation of input and output streams, providing a unified interface to the outside. Common GMF IO implementations include Fire, HTTP, Flash, and I2S. Now, let's look at the components of the GMF. First, let's look at the GMF element, which is an important part of the pipeline. It provides consistent working function for each element, including open, process, and close operations. It also offers four port management methods and ways to access the functional capability of each element. GMF elements can derive various special categories such as audio elements and picture elements. Audio elements instantiated classes include encode, decode, and decrypt. encoder, EQ, mix, resample, and other audio algorithms. Picture elements classes include JPEG encoder and decoder, PNG decoder, and more. GMF port is the data input and output port for an element. An element has at least one port, and the port's connectivity is defined by the element itself. GMF method provides a way to access element function through a unified interface based on GMF args. GMF args is used for the parameter serialization of function. Please refer to the finger out on the right for its structure. GMF port is a connection port of an element capable of connecting to various types of ports, such as callback function and the GMF database. GMF port has the ability to manage payloads, adjusting the size of the payload buffer based on the element's connection and required data size. Additionally, it enables data addressing between elements. GMF databus provides a unified data access interface, which used a query release to access data. Data transmission supports two transmission modes, zero copy and copy, as well as blocked and non-block access methods. At present, GMF supports three kinds of databus, namely RAM buffer, P buffer, and block buffer. All three interfaces are thread safe, of which P buffer and block buffer data transmission are zero copy. RAM buffer and block buffer provide the blocking interface that can be called in different threads. GMF task is the thread that executes jobs. It takes job from the work list to run. When the job of the work list is executed, it will enter the idle state until new job is added. Job is the smallest unit to perform work. Job is divided into one time and unlimited times. Generally speaking, a pipeline has only one GMF task. A picture on the right is the basic workflow diagram of the GMF task. GMF pipeline supports pipeline cascading, allowing one pipeline to connect to another with events from one pipeline cascading to the downstream pipeline. It also supports the sequential startup of event-dependent elements. For example, in a pipeline with two elements, a decoder and a resampler. Well, the resampler depends on the music, information passed by the decoder. GMF pipeline will start the decoder first. The resampler will only start once the music info is available. This process simply operation without noise. The pipeline supports controls such as run, stop, pause, resume, and reset. The GMF pipeline is a model that operates independently with GMF. It handles events for connected elements and tasks, and is responsible for managing in and out ports. During operation, the pipeline also registers jobs for connected elements. Typically, a GMF pipeline consists of one GMF task, at least one element, one import and one output. The import connects to the input of the first level element, while the output connects to the output of the last level element. A pipeline can have one or more elements, limited only by physical constraint. GMF pipeline is highly flexible. Here are four basic pipeline applications. The first diagram shows a pipeline for decoding audio from a file and playing via I2S. The second diagram, the pipeline's input and output are not connected to ports, but used a callback function to a known user to provide the data. The third diagram illustrates a pipeline split into two parts, connected by a ring buffer in the middle. The fourth diagram shows two pipelines connected to a mixer pipeline, used for multi-channel mixing with a single output. The pipeline described here is more complex and is designed for intricate case involving shared data. For instance, during music playback, audio data needs to send to an uh, AEC for reference. The finger shows a copper element with a single input and multiple outputs. Its output can be connected to multiple pipelines as well as other types of outputs. This part introduces the ESP GMF workflow. Now, let me introduce the sequence diagram of the pipeline. When the pipeline run API is called, it invoke the run API of GMF task. The GMF task executes the blocking state and performs initialized tasks, including calling the running callback to open the connected in and out ports. After completion, those operations, a running callback is sent to the application layer. Only after all those functions return does the pipeline run function exit. After the pipeline call run, it enters to the running state. During operation, if an element emits an event, the GMF task will notify the pipeline. The pipeline will then notify all connected elements of the events. Each element uses the event information according to its own requirements. If the element meets the operation requirements of an element, the element state will switch to initialized, ensuring that the elements will be added to the work list during the pipeline's later loading phase. Once all element tasks are added to the work list, the pipeline continues to run into a loop. Well, in the running state, calling pipeline stop can premature stop the pipeline's execution. Once pipeline stop is invoked, it will call stop on GMF task. GMF task will first clear the loaded work list. Then the pipeline will add the closed jobs of the connected elements to the work list. After all the closed jobs are completed, A stopped event will be sent to the application. Once all those operations are finished, the GMF pipeline stop will exit. The process of the finished and error are similar to those calling pipeline stop, with the key difference being that finished and error are triggered by GMF task itself without requiring user API calls. After finished and error occurs in the pipeline, GMF task will first clear the loaded work list. The pipeline will then add the closed jobs of the connected elements to the work list. Once all the closed jobs are complete or finished and all, all error events will be sent to the application. After all those operations are complete, the GMF pipeline will stop running. Here is an example and a performance comparison. This is an example for playing music from SD card. Use the ESP GMF. Let me switch to my code window. Here, uh, the first uh, the first line we mount SD card and install the I23 drivers, and those code we register the IOs and elements to the DMF pools. After that, we can new a pipeline with the name and in out port string. After that, we set the URI for the import. Here, we correct the GMF task for the pipeline. And here, we bind this thread to the pipeline. Call this line GMF pipeline run. We can run in the pipeline. I will build in and download this code to ESP32 S3 board. Wait a second. This is my test board. Okay, here we go. The sounds come from the speaker. Yeah, it's done. Yeah, this side, we compared the resource overhead of GMF and ADF on the ESP32 S3. For detailed data, please refer to the two tables. We tested the three audio source, SD card, flash, and HTTP. And each source, we have two pipeline structure, one using resimple and one not using resimple. So there are two test cases in total. The table shows the GMF saves an average of 29% in memory usage and reduce CPU loading by an average of 7%. This greatly simply and the integration of audio functions into resource-limited chips. That's all. The above contents is my presentation. Thanks for watching. If you have any questions, please feel free to contact us through GitHub or our sales teams. Thank you.